You know, for as long as humans have looked up at the night sky, one thing has always been there, watching over us. It's our closest celestial neighbor, a silent guardian, and a place that has fueled our dreams for thousands of years. So today, we're going to take a deep dive into Earth's moon. But first, to really get a sense of this journey, let's start with a number, 238,900 miles. That is the average distance between us and the moon. And to put that into perspective, it's a gap so huge you could literally fit every single other planet in our solar system into it, side by side. So yeah, even though it feels close, that vast distance really sets the stage for our story.
So here's our plan. We'll start with the basics of our constant companion. Then we'll get into its absolutely violent birth. After that, we'll take a tour of its cratered surface, understand its dance with the Earth and Sun, and finally, look at why it's so important for our past and our future.
All right, let's jump right in. Section 1, our constant companion. I mean, we see it all the time, right? But what is the moon, really? Let's break down some of the must-know facts about our closest neighbor. Okay, so first off, it's our planet's one and only natural satellite, and it's about a quarter the size of Earth. But get this, a single day on the moon, from one sunrise to the next, lasts almost a full month here on Earth. Just imagine that, 14 straight days of blistering sunlight, immediately followed by 14 days of bone-chilling, freezing darkness. And the reason for these extremes? There's just no weather, no wind, no rain, nothing to protect or change the surface. It's like a perfectly preserved museum floating in space.
And this is the perfect example of what that means. Because there's no wind or water to erode anything, the footprints left behind by the Apollo astronauts over 50 years ago, they're still there, just sitting there, perfectly preserved. And they could stay that way for millions of years. A quiet, frozen monument to the very first time we stepped onto another world.
So how did this thing even get there? Well, the moon wasn't always hanging out in our sky. Its origin story is just incredible. A tale of unimaginable violence and pure cosmic chance that takes us all the way back 4.5 billion years to the very beginning of our solar system.
The leading theory is as epic as it gets. It's called the giant impact hypothesis. The idea is that way back when our solar system was basically a chaotic construction zone, a baby planet about the size of Mars, which scientists have nicknamed Theia, came hurtling in and just slammed into a young, molten Earth.
So here's how it likely went down. First, you have this catastrophic collision. Then, that insane impact vaporized huge chunks of both planets, blasting a superheated ring of molten rock and debris into orbit around Earth. And finally, over thousands of years, gravity just did its thing, slowly pulling all of that material together until it clumped up and formed the moon we see today.
But you might be wondering, how can we be so sure about something that happened so long ago? Well, the clues are literally written in the rocks. The samples brought back by the Apollo astronauts are chemically almost identical to Earth's crust. Also, the moon has a tiny iron core, which makes total sense if it was formed from the lighter outer layers of Earth and Theia. And to top it all off, our supercomputers can run the simulation, and they show this exact scenario actually works.
Okay, so that's how it was born. Now let's go explore the world that was created. If you were standing on the surface right now, what would you actually see? Let's take a quick tour of this cratered, silent world.
The lunar surface is just a stunning landscape of contrasts. You've got countless craters, which are the scars left behind from billions of years of meteorite impacts. Then you see those vast, dark patches called Maria. Early astronomers thought they were seas, but they're actually smooth plains of ancient dried lava. Contrasting with them are the bright, rugged highlands, which are the moon's original, older crust. And covering everything is a fine, powdery gray soil called regolith. It's made of billions of years of pulverized rock and glass, and they say it's finer than sand but as sharp as glass.
Okay, now let's pull our view all the way back to Earth and look up again. The moon isn't just sitting there. It's locked in this constant, predictable dance with the sun and the Earth. And that dance creates some pretty beautiful effects for us down here.
The most obvious result of that dance, of course, is the phases of the moon. And the key thing to remember here is that the moon isn't actually changing its shape, not at all. It's just about the angle of the light. Imagine a single lamp in a dark room. As you walk around a ball in that room, you'll see different parts of it lit up. Well, we're on Earth, the sun is the lamp, and the moon is that ball. From new moon to full moon and back again, it's all just our changing point of view.
And every now and then, that dance lines up perfectly, and we get an eclipse.
During a solar eclipse, the moon gets in the way and blocks the sun. Simple. A lunar eclipse is the other way around. The Earth gets in the way and casts its shadow on the moon. The easiest way to remember is to just think about what's being blocked, or eclipsed. And that brings us to our final section. Because the moon isn't just a pretty nightlight, it's a fundamental anchor for our planet, and it holds a major key to our future in space.
I mean, the moon's influence on Earth is just profound. Its gravity pulls on our oceans, creating the tides, a rhythm that has shaped life for eons. But even more important, its gravity acts like a giant gyroscope, stabilizing Earth's tilt. Without the moon, our planet would wobble like a crazy spinning top, causing wild climate swings that would make complex life, like us, pretty much impossible. It's the reason we have predictable seasons.
And of course, the moon has also been our destination. The legendary Apollo program put humans on the surface 6 different times between 1969 and 1972. But after that last mission, we just didn't go back for over 50 years. Now, that ambition is finally back with NASA's Artemis program, and this time, the goal isn't just to visit, it's to build a sustainable, long-term human presence there.
And you really can't talk about going to the moon without hearing these famous words. That's one small step for man, one giant leap for mankind. A single sentence that captured the spirit of a generation and just completely expanded what we thought was possible. So, as we look to the future, we're left with this really fascinating question. With all these new plans for permanent bases and using its resources, is the moon destined to become humanity's next home? Or is its real purpose to serve as a crucial stepping stone, a launch pad for the even bigger journey to Mars and beyond? The final chapter of that story is still being written.